All right, so we are talking about combined transformations today. So we are going to be working with a lot of times 3 images. So we're going to have the original image, which doesn't have any apostrophes. We're going to have the prime image, which has 1 apostrophe. And then we are going to have the third and final image, which has 2 apostrophes. All right, so if you look here, let's do this like one transformation at a time. So going from red to blue, from original to prime, what does it look like is happening?
Reflection.
A reflection. I agree. And which axis is it reflecting across?
The Y.
The y-axis. So I agree with you. Our first transformation is reflection across the y-axis. So a good way to tell which axis it is look at which axis is in the middle of the 2 triangles or the 2 squares. And that'll tell you which one it's reflecting over. Okay, going from blue to green, or the prime to the final image, what does it look like is happening? So a couple things. Are they the same size?
Yes.
Yes. So we'll go ahead and say that this is congruent because they're the same size. So since it's congruent and they're the same size, a dilation would not be an option. Okay, are the letters or the vertices in the same location?
Yes.
So B is on top, A to the right, C to the left.
Yes.
So a rotation or a reflection are not a choice. So what's the last choice?
Translation.
Translation, where it just slides. So figure out what direction and how many it had to translate.
To the final image?
So from the blue to the green, how many did it have to move?
3 down 4.
Right 3 down 4.
Is that from top?
From blue to green. Yeah, from B to B. Like go from one letter to the matching corresponding.
I was going from red to blue.
Okay. All right, so on the next problem, we aren't given a graph. We're given a graph and we have to graph our own figure. I would recommend when you're graphing these, we go from original to prime and figure that one out, and then we graph the final one and then figure that one out. So we do it kind of like step by step. So I want you to graph the original and the prime, and then we'll stop and figure out what the transformation is.
What?
So graph the original and the prime, the first and second one.
Isn't it? This is set up. Is the line set up on the x-axis? Isn't that set up on?
Mm-mm. Okay, so looking at these 2 parallelograms, what does it look like is happening as far as the transformation?
Reflection.
A reflection, I agree. And which axis would it be reflecting? The x-axis. So the first transformation is a reflection over the x-axis. Okay. All right, so now I would go and graph the final third image, and then we're going to do the transformation from the prime to the final. Okay, so if you look at the letters, that helps you determine what you think it is. So are the letters in the same location
No.
from red to blue?
Yes.
Yes, they are. They didn't change sides. Like DC is on top on both of them. So what would this have to be?
Congruent.
They're congruent.
The translation.
It has to be a translation where it just where it was sliding. So translation, and figure out how much it had to move in what direction.
Left 4 and down 3.
Okay, left 4, down 3. And then also we have determined that these are congruent. Okay, so when we look at the next one, the graph, the figure's already graphed for us. So we're gonna do this one at a time. We're gonna go from original to prime, so red to blue, and figure out what transformation happened. So are they the same size, red to blue?
Yes.
Yes, so it's not a dilation. Are the letters in the same direction? Is it facing the same direction?
No.
No, so it's not a translation where it just was slid. So it's got to be a rotation or a reflection.
Rotation.
Rotation. Okay, how did it rotate?
To the left, to the right.
Counterclockwise.
To the right. So, okay, AB went from being vertical to being left and right.
It still went to the right.
So it went to the right, which is what direction on a clock?
Clockwise.
Clockwise. And how many degrees did it turn?
90 degrees.
90 degrees clockwise.
How do you know that?
Because it went from straight up and down, like north-south, to running east-west. So that would be, it went to the right, which would be clockwise. If it went this way to the left, it'd be counterclockwise.
Yeah, but how do you get 90 degrees?
Because it made one corner turn, like with one corner. Like 1/4 of a turn
Man, yeah, because 90 is like 1/4
of a circle. Yes.
Okay, I see it now.
Okay, so from blue to green, what happened?
Dilation got
They
big.
got
It
big.
got bigger. It's a dilation. How much bigger did it get?
2 boxes. Or 2.
2. I agree, because this is a 1x3 rectangle and this is a 2x6. So it doubled. And then are all 3 of these rectangles congruent?
Yeah.
No. If they're not congruent, then what are they called? Similar.
I thought dilation was smaller.
It could be smaller or larger.
Isn't that reduction?
Yes. But they're both dilations technically. Well, you just call one a reduction. Okay, so next thing we're gonna do is the same. We have 3 different images to graph, so we're gonna graph the original and the prime and figure that out first, and then we'll graph the final one. So go from original to prime. Okay, so did the rhombus or square parallelogram, you could call it any of those things, did it change size?
No.
No. Okay, so dilation is not an option. Are the letters facing in the same direction? No. So it's not a translation. It didn't slide. So we have rotation or reflection. Okay, if it was a reflection, if it was a reflection, we wouldn't have had D and B flipping like we do up here. You guys see that? Because on the first problem, B is on top, D is on the bottom, and on the second,
So then it's not
it's
a
switched.
reflection.
So it's not a reflection.
It's in 180
Then it'd
degree
be a-
rotation.
Okay, I agree. 180-degree rotation, like it completely turned upside down. So 180-degree rotation.
It's a dilation.
Okay, so now we're gonna graph that final image. And you're gonna have to graph on decimals, but just do your best, like 0.5.
Oh,
It's a dilation.
yeah. There's 5. That's the dilation.
So it became smaller, so it is a dilation. How much smaller did it become?
It looks like a
No.
box. Looks like.
So if you look at your coordinates, it went from -1 to -0.5 and -3 to -1.5.
So 0.5.
So it was cut in half essentially, right? So it's a dilation by half. And is it congruent? Similar.
Would it like kind of be a reflection with red and green? Cause like they're both the same, just one's smaller than the other.
It wouldn't be a reflection unless it crossed over an axis. Like you'd have to cross over the y-axis. Okay. All right, so we have a combined sequence of at least 2 combined transformations to get to the final image. So we're essentially missing the middle image right here. So we're going from red to green and we're missing what's in the middle. So we have to try to figure out what could have possibly happened. Any ideas? And this particular question, you do not have one like this on your test. So this is completely just like a challenge question. Okay, yes.
Yep. It wouldn't be a reflection, right? Cause it's not on
No,
It's like-
it could be a reflection.
No.
What if it's
the. No, cause
reflection?
it's not like straight across.
Okay. At some point, I'm going to have to twist my triangle, right? To turn it.
Yeah.
I think there was a transformation or translation.
Translation at some point. Okay. Yes.
I could just a rotation 90 degrees.
Okay, so if I rotated by 90 degrees, let's try that. Look at your chart and tell me, how do I rotate 90 degrees? In which direction would it have to go?
Right.
It has to go right, which is clockwise, because it's going from red to green.
Wait, where does it say?
So if you look at your chart, how do you do a 90-degree clockwise?
Multiply each x coordinate by -1, then switch the x and y coordinate.
Okay, so A is -4, 5. So we're gonna take x times -1 and then flip flop.
And that just.
So that'd be 5, 4. So now let's look at B. B is -2, 5. So same thing, x times -1 and then flip it.
5.
5, 2. And then C is -2, 2. So C prime would be 2, 2. So
That's
let's
wrong.
graph that and see what it looks like.
Yes, it is, because.
No.
Yeah, because the green triangle isn't positive numbers. What?
It doesn't. No, we're trying to find what the.
We're trying to
middle
find the
one
middle one is. We're trying to find what the middle one is. So this one was a 90-degree clockwise.
What?
Okay, now what would I have to do to go from prime to the final?
Translation.
Translation. And what would I have to move it?
4 boxes.
5 down.
Yeah, so I would just have to go 5 down. I wouldn't have to go left or right. And are all of these congruent?
Yes.
Yes. So like I said, this question is not on your test. This is just like a challenge question.
That was challenging.
Oh, it's confusing.
Okay. I'm gonna switch to your homework assignment, and you do get graph paper with your homework assignment.
I'll start keeping my book in here.
Hold on.
They were